Welcome to ThinkDart, where we explore the mysteries of space, time, and the future of humanity. Today, we ask one of the boldest questions of all. Can humans one day travel to the stars? Interstellar travel has long been the dream of science fiction writers and visionaries, but new science may be pushing this dream closer to reality. Let's dive deep into the challenges, theories, and astonishing breakthroughs shaping humanity's next great leap. The impossible dream, humanity's restless spirit. For as long as humans have looked up at the night sky, we've wondered what lies beyond. From the Polynesians navigating the Pacific to Apollo astronauts landing on the moon, exploration has defined us. But now, the next frontier isn't another continent or even another planet. It's the stars themselves. Why? Because space is unimaginably vast. The nearest star system, Alpha Centauri, is over 4.2 light-years away. That's 25 trillion miles. With current rockets, it would take tens of thousands of years to get there. Yet despite the odds, scientists are already laying the groundwork for humanity's interstellar future. The speed limit of the universe. The first hurdle, Einstein's theory of relativity. According to physics as we know it, nothing with mass can move faster than the speed of light. That means reaching another star requires technology far beyond our current rockets. To put this in perspective, Voyager 1, our fastest space probe, is leaving the solar system at 38,000 miles per hour. At that speed, it would take over 70,000 years just to reach Alpha Centauri. So, if interstellar travel is ever to happen, we need revolutionary propulsion systems, or ways to bend space-time itself. Breakthrough Starshot. Tiny ships, giant dreams. One of the most exciting modern projects is Breakthrough Starshot, backed by physicist Stephen Hawking and billionaire Yuri Milner. The idea is simple but radical. Launch thousands of tiny probes, each no bigger than a microchip, attached to light sails. Gigantic ground-based lasers would fire at these sails, accelerating them to 20% the speed of light. At that velocity, the probes could reach Alpha Centauri in just 20 years. While these probes couldn't carry humans, they could send back precious images and data, proving interstellar exploration is possible. Fusion rockets and antimatter engines. For crewed interstellar missions, scientists are studying more advanced engines. Fusion rockets, powered by the same reaction that fuels the sun, could reach speeds of 10% of light. Antimatter engines, in theory, could be even more efficient, but antimatter is extremely difficult to produce and store. Still, experimental fusion research, like the ITER project in France, is pushing us closer. If we can crack sustainable fusion on Earth, it could unlock the propulsion we need for deep space journeys. Bending space and time. Warp drives and wormholes. Beyond propulsion, there are ideas straight out of science fiction. In 1994, physicist Miguel Alcubierre proposed a warp drive that could contract space in front of a ship and expand it behind, moving faster than light without breaking physics. It requires exotic matter with negative energy density, something not yet proven to exist. Wormholes, shortcuts through space-time, are another possibility. Recent research shows they might be theoretically possible, but stable wormholes would require huge amounts of negative energy to stay open. Still, physicists continue to explore these ideas. Generation ships, a journey across centuries. If faster-than-light travel remains out of reach, another idea is the generation ship, a massive, self-sustaining spacecraft where entire communities live, work, and reproduce over centuries until their descendants reach the destination. Such ships would be technological marvels, rotating habitats to simulate gravity, closed ecosystems to recycle air and water, and advanced shielding to protect against cosmic radiation. It wouldn't just be a mission, it would be a new civilization in space. Cryosleep and suspended animation. Another approach is putting travelers into deep sleep for the journey. Scientists are experimenting with lowering body temperature to slow metabolism, potentially allowing astronauts to survive long trips in hibernation pods. While still in early research, NASA has studied concepts of torpor for Mars missions. If perfected, it could be the key to interstellar voyages lasting decades or centuries. the human side, ethics and philosophy. But interstellar travel isn't just a technical challenge, it raises profound ethical questions. Should we risk sending humans on voyages they may never return from? How would generations born in space view Earth, or even humanity? What happens if we encounter alien life? Becoming an interstellar species means reshaping not just our technology, but our identity as humans. Why interstellar travel matters. Some ask, why bother? Earth is our home. But history shows us that exploration drives progress. Interstellar travel would safeguard humanity from extinction, expand our horizons, and answer the greatest question of all, are we alone? And even if we never reach another star, the pursuit of this dream pushes science forward, fueling breakthroughs in energy, materials, and space exploration that benefit life on Earth. Interstellar travel is humanity's boldest dream. Today, it seems impossible. Tomorrow, it could define our destiny. From light sails to warp drives, from generation ships to cryosleep, every step brings us closer to the stars. So, what do you think? Will humanity conquer the distances of space within the next few centuries? Or will interstellar travel remain forever in the realm of science fiction? Comment your thoughts below and don't forget to like, share, and subscribe for more journeys into the unknown. This is ThinkDart, and the universe is waiting.